Okay, these are radical properties, and radical properties are completely related to exponent properties, because as we know, if I have something like, I'll put actual numbers in here. If I have something like 3/4 power, and then I have the 5th root of that, I can rewrite it as power over root. So exponents and are completely related. They are the same thing, just in different formats. So all the rules that we were talking about with exponents, they also apply to radicals, but only like radicals. Because remember, when we do things with exponents, they have to be with like bases. So with this 3, that would be my base. Actually, 3 to the 4th would be my base. And the root part would be the 5. That would be the radical part of it. So when we start doing, we're talking about doing these properties with like bases. Or, well, no, it's not like. It has to be like. What does it have to be? I'm not explaining it very well. Oh, it's, yeah. Okay, so here's some rules that we're allowed to use. Product property says, and it goes both ways, so I'm going to start with this one first. If we are multiplying two roots that have the same index number, the same root, you can actually multiply those numbers together. So it's the same thing as that same root, and the two just numbers multiply together. So here's an example. If we're doing the cube root of 4 and the cube root of 2, which I don't know the answer, I can multiply the 4 and 2 together and do the cube root of 8, which I do know the answer to. So we can multiply roots together if they have the same index.
And then is the index stay the same?
Yes. You just multiply the stuff underneath and keep the same index. And then this one we were able to simplify. Sometimes we can't, but that one we could. And the quotient property is the same way. If I am dividing the same index, I can actually divide what's underneath the index with the same index around it. Or if I have a root of a fraction, I'm allowed to separate that root into separate pieces. It just depends which way helps you more. For this one here, if I have the 4th root of 162 and the 4th root of 2, I don't know the 4th root of 2. But if I combine them using the quotient property, I can actually divide 162 by 2, and I get the 4th root of 81, which I have an answer for, 3. So these are used to manipulate these questions to make it easier to simplify. So here, do I have the same root? Yeah? Okay. So if I would like to simplify this, I do not know the cube root of 12, and I do not know the cube root of 18, but I can multiply these together. And I don't know what 12 times 18 is. $216? And then we say, ooh, I think that was on my list of perfect cubes. Let me go check my list, or I have it memorized. That is a perfect cube. It's 6. 216, yeah. All right, and then the next one, I do not know the 4th root of 80, and I don't know the 4th root of 5. But if I use this quotient property that says I can take the 4th root of 80 divided by 5, 80 is divisible by 5. So now I have the 4th root of 16. And I should know the 4th root of 16 is 2. This would be non-calculator stuff. The hardest you might have to do would be multiplying 12 times 18 by hand. Oh no. Okay, so yeah, we're going to have a quiz after we finish section. It'll probably be Friday, 5 to tomorrow, and then we'll take all of block day for reviewing. All of block day Friday. Go on your long weekend and be like, Okay. Student practice. Cube root of 4? You know it? No. Okay. Cube root of 128? Okay, if you don't like multiplying 4 times 128 the traditional way, so do like 4 times 120 plus 4 times 8. What? You can break it down by place. I'm just showing other ways of doing it. And I know you all know the third root of 512, don't you? It's on the list. It's on the list. Fifth root of 192, fifth root of 6, I don't know those. So I'm going to separate it. I mean, not separate it. I'm going to combine it and do 192 divided by 6, and hopefully that goes even. Oops. I'm a little dyslexic. Oh my gosh, you're taking away my joy telling the answer. I wanted to do long division. Okay, it's 32. So now we have the fifth root of 32. What's wrong? Okay. Into 19. 6 goes into 19 3 times. How'd you get a 6?
What do you think it was like? Oh, I have. Close the answer.
Okay. That's okay. We are skipping example 3 because the way I set up your notes, I'm going to skip some of the harder radical stuff. I'm going to do A, but I'm not going to do B because of tomorrow. So we are going to go over A. It says to do the cube root of 135. 135 is not a perfect cube. So what we're going to do is we're going to make a little factor tree like we did for square roots. Only we're going to do it with cube root. So your goal is to find what goes into 135. So we start thinking about perfect cubes. 2 number that goes into 135 that you know for sure.
5.
How many times does 5 go in? This might be easier to do this way. 2. I don't think it's 29.
26. Yeah, it's 26 point. It's just 26.
I'm dyslexic.
It's 26.
Okay, so I was like 5. What's that leave me with? Is this by any chance, this 27, is that by any chance a perfect cube? What I want to do is separate this into a perfect cube and whatever else. And I don't know the cube root of 5, so just bring that down. It's the same way we did square roots many times, except now we're doing cube roots or fourth roots or fifth roots or whatever. So you have to separate it into a perfect cube and the rest of that. Okay? We're going to save for tomorrow this one. Let's see. Let's try number 7. 5 and 6 examples of. Let's look at number 7. 104 is not a perfect cube. Can we separate it to a perfect cube and whatever else. What do we know about 104? Even? 2 times 52. That's not going to help me. Is 4 a perfect cube? Okay. 26 times?
No, 104 divided by 4 is 26.
Right, but are either of these perfect cubes? It is not a perfect cube.
So then that was not.
Okay. What's another even number that is a perfect cube? I wonder if 8 goes into 104. How many times? 13 times. So I'm going to do 8 and 13. And what is the cube root of 8? 2 cube root 13. And then number 8 we have to save for tomorrow. So I'm not going to spend time to do that one today. Yep. Okay, so what I'm doing today is things that I feel like we can easily get through without teaching you a ton in one day. So that's why I'm kind of skipping around a little bit, and you'll see the homework skips around a little bit too. So I actually skipped an entire page. So now I went all the way to example 5. I'm saving some special stuff for tomorrow. Trust me. I know what I'm doing. Trust me. Yeah. What? Do you have a plan? All right, so question A in example 5 says simplify each expression. So you guys, when we add anything in math, what do we have to have? Like terms. Anytime we do addition, you just have to know what the terms are. So the coefficient is how many you have of your like terms. So my coefficient on the first one is what number? So my like term should be 4th root of 10. Skipped a whole page. We're on example 5. So on my second term, I have 7 for my coefficient, and I have 4th root of 10. Okay. So I do have like terms. If I have like terms, I can add how many of those like terms I have. So I have 1 plus 7, 4th root of 10. So I have 8, 4th root of 10. That's what you do for addition, yeah. Now look at number 2. I mean B. We've got 2 of these plus 10 of that exact same thing, 8 to the 1/5. So 8 to the 1/5 must be the like term part. We've got 2 of them and 10 more. Do you know what I just did right here? I just used the distributive property to factor out 8 to the 1/5. Remember the distributive property with factoring? GCF? You don't remember factoring out the GCF? Factored out the GCF? I just put the parenthesis in front instead of behind. All right, so what's 2 plus 10? 12, parenthesis, 8 to the 1/5. That's the answer. C. Do we have like terms? Katie, do we have like terms for C? No, not like indexes. So my coefficient here is a 1 and my coefficient here is a 1. But like this would be what determines if they're like terms. The cube root of 54 and the cube root of 2. They are not like terms yet.
We can make them like terms.
Perhaps. I hope we can. So we're going to actually, 2 I cannot break down any further. But 54, perhaps there is a perfect cube that goes into 54. What perfect cube goes into 54?
9 and 6.
Neither of those are perfect cubes. We need to know of perfect cubes, like 2 to the 3rd is 8, 3 to the third is 27. 4 to the third is 64, which is already bigger than 54. So if you got any options inside of these two? Does 8 go into 54? It's 27 times. Here's a hint to you. Here's a hint to you. If you're getting problems from the book, they usually come out pretty nice. This is a 2. So if I want to be able to make like terms, there's probably going to be a 2 cube. I divide by 2 and 7, and I'm like, oh, that is the perfect cube. So I have 3 cube minus 1. Three minus 1, cube root 2 is 2. Cube root 2. Question? Oh, you just need to move closer? Oh gosh, the next 3 look like you try. Yeah. Come on. What is it? I do not know where you're talking about. Oh, you mean for square root? We use the most. So it's just kind of like assumed that it's a square root. Where if it's any other root, you have to tell me what it is. But we just assume a square root because it doesn't have anything. It's just like common. So we just all know that that's the square root. There's other things in math that are like that. For example, what's my on? But there's not a 1 there. Or what is my? But there's not a 1 there. Like these are things that we just kind of know. But then if it's other things, like if right? Okay. Same kind of concept. So number 10, are they like roots? Sorry, Rachel, you had a question. Then they're not the same. Like in order for these to be like terms, the index and the stuff underneath the radical, everything has to be the same to be like terms. The little 5 is the index. Exponent. So we have 5 roots, 5th root of 12s. Take away how many 5th root of 12s? 1. 6 5th root of 12. I know what you meant. All right, so this one, do we have like terms? So we got 4 of them plus 8 more, 12 of those same things. Wait. What's 5 and 8? Oh, I thought you meant you didn't understand this 12. Okay, next question you don't understand. So now we have a 5 here, and this does not match. So if we break it down to cube root of 8 multiplied by the cube root of 5, 2 cube root 5. We take the cube root of 8, which is why I chose 8, because it went into 40 and it's a perfect cube. And then the first one is still just cube root of 5. So I'm thinking like how many are in this first one? 1. It's not written there, but we assume there's 1. Right, so we get 3 total cube root of 5s. So coefficient is telling us how many cube root of 5s we have. Done? We're not done. Oh my gosh, you guys waste so much time. Hey, nope. I'm trying to think. Oh my gosh. So I don't think I have enough time to do the radical stuff, so I'm have to tweak your homework a little bit. Yeah, tweak away, right?
Yeah, I know.
So if the bell rings, I have 2 minutes to fix this. If the bell rings and I haven't fixed it completely, if you're going straight to study hall, you may want to just wait a second. I think I'm just taking off the end, but I gotta go double check with the book real fast. I'll zoom in so you can write down the assignment.
That's on Canvas.
Yes, I know. But I'm just saying, like, I'm going to have to change the numbers on Canvas, so I think it's the end that I have to change. If you do not go check Canvas and the bell rings, and I haven't fixed it, if I haven't told you what to fix yet, then you're going to be more work than you have to, and you probably might get stuck. Maybe not, but maybe. I just got to find this page so I can fix it. No, paper. Guess what? Guess what? I think you can do it all. I think you can do it all. You might have some questions on 65 to 72, but I think you can do it all.
We wanted to just turn this to no.
Nope. Go ahead and complete it and we'll grade it tomorrow.
I'm struggling. I can still outrun you. When you want to be respected, I'm fast. I can still. Bruh. Any sport. Any sport that can outrun me in life. I can beat you in minutes.
I am adding in a screenshot of the book if you want to use it.
Any sport that you can beat me in, you can probably beat any sport. I can beat.
Did you guys hear what I said? Those of you that care.
I care what you say. What did they do? Football. Yeah, I can. Probably can't. I've seen you play. But if we played against each other one-on-one and you were trying to guard me, you would not be able to. And if you're right in front of me and I'm right towards you, you would be bad.